Hello to everyone. Today we are going to be talking about the project Monitoring Marine Plastic from Space, a simulator for remote sensing of marine litter that we are going to call ML-OPSI from now on. It is an ESA-funded project and we started it with our partner Sungu Garaba at the University of Oldenburg. What is the concept behind ML-OPSI? The Optical Performance Simulator, OPSI, is a breadboard for operations research in Earth observation of marine litter. This breadboard aims to provide a framework onto which the components of an Earth observation mission can be specified and tested for performance quickly and without coding experience. It manages the connectivity between components and provides commonly needed functionality, such as diagnostics. So ML-OPSI will be a virtual laboratory where different models, conditions, etc. could be tested. The desired outcome is then assessing the optimal characteristics required for a sensor design with an aim to detect aggregates of marine litter. So to do a mission feasibility study considering the sensor, the spatial resolution, spatial coverage, acquisition time, and the litter aggregates and background. We have focused on patches of accumulations and windrows as individual pieces remain below detectable limits. Besides, we have to consider that its detection depends on several factors, such as the spectral signature, which will depend on the density and type of marine litter present, and if these materials are floating or if they are partially or totally submerged, dry or wet, etc. Also, what are the characteristics of the satellite, such as the spatial resolution that we need to detect those plastics? So ML-OPSI objective is to aid answering the question, what should be the specifications of a sensor to detect marine litter? As you can imagine, to consider all the different parameters and conditions that could impact our ability to detect plastic is a challenging task. And in order to assess and add the different parameters and factors that will impact the detection, we have then designed ML-OPSI as a generic pluggable system that uses a component-based architecture to construct domain models. In this instance, marine litter detection performance assessment and optimization for the purpose of planning future missions, and as a breadboard to experiment, for instance, in the development of new algorithms. We have been talking about the system and how it is generic and pluggable, but let's put the model, marine litter, in context with the simulation system, OPSI. The model and OPSI are decoupled. Essentially, we have designed a generic Earth observation simulation system that can be customized for different missions and purposes, that it is extensible part of the system that we propose. We have break it down into digestible tanks, and a top-level system architecture identifies a set of components that are needed to represent the domain model and the simulator platform. For example, the scene generation module is the critical component and the most complex, as we can see that it has different modules, such as, for example, the litter raft module or the ocean dynamics. The next step, after the definition of the technical requirements of ML-OPSI, was to show the utility of a tool as such. However, when developing the litter module, we could follow three different approaches. The first one was to develop a full mechanistic model of all the components, which is a huge model, mechanistic and parametric modules, computation dynamics, so it is out of the scope. The second option was to use drone imagery as BOA input and proxy, supported by Luis Barbero from the University of Cádiz and performed by Sungu Garaba. And the last option, to develop a demo using laboratory measurements and a model for the litter module, which is the one that we present here. As we have said then, so far we have defined the big picture, and now we wanted to show you the demo version of ML-OPSI, which is a proof of concept to show that what we have defined technically is compatible and can be done. So it is a standalone demonstrator which was built as a rapid prototype, including implementation of three modules: the scene generation module, the atmosphere module, and the instrument detection module. And we have defined the scenario builder as a GUI with a GUI option. Here we present you the ML-OPSI demonstrator where we can see the different modules. We have the scene generation module where we can select the different types of litter which are coming from the dataset that we have composed thanks to peer-reviewed paper. then we can select the number of items that we want, that we have to consider that the sum of the fraction of those liter types have to be lower than 1. Then we can select the water type, and we combine these two reflectances thanks to the model of Godin, Murphy et al. 2018. We can also run the atmosphere module, which uses the Pi6SV software, and then we can also select the instrument detection model. We run the simulation, and once this simulation is finished, we can plot the different results. Here we are going to show you the remote sensing reflectance coming from the different liter types that we use for the simulation. Then we can also select the BOA reflectance and the TOA reflectance as well. And we can superpose the TOA values for the sensor that we selected, in this case Landsat 8. And then we can save all the outputs in CSV files. Here we present you some generated examples using different concentrations of liter items. This could be used as a virtual laboratory, as said, to test different models and algorithms when trying to detect plastic litter. In conclusion, we would like to further develop the demo if it's of interest to the community. And for that, we will need an overall approach to evolve with the community. What is the common development to follow? What are the specifications going to be, for example? So thank you very much for listening, and have a nice day.